Hi, doing a quick video on relative extrema and critical numbers and critical values. So let's talk about what some of these terms mean. So we can look right here. We see some basic guidelines, some rules. It says definition of relative extrema. 1, if on an open interval there is a C value, some C, which is another word for X or a letter for X, on which f of c, so when I plug that c back into the function, I'll get some y value. That's what f of c is a y value, is a maximum. So if it hits a high point, then f of c is what we call a relative maximum. Now, we can do the same thing for minimum. Now, normally the definitions will keep a c value, but I changed it to b just so when we look at the graph, we'll notice the differences. But if on an open interval there is some b value, which f of b is a minimum, then f of b is a relative minimum. So we're talking about relative minimums, relative maximums, as well as we're also going to look at what's an absolute max or an absolute min. And then you might also hear some different words and terms used like local min and local max. Local minimums and local maximums are essentially the same as your relative mins and max. All right, so let's look at a graphical representation of what this does. So here we have just some function in blue, and we notice that at some c value, it does produce a relative maximum. We notice that as the function comes from negative infinity to c, the function is increasing, right? It's increasing. But when we get to c, now the derivative, right? The derivative has gone from a positive to a 0 or horizontal line. So that's one aspect of a maximum or minimum, is that the derivative is 0. So we move along and we find another. Now down here we would have a relative minimum. As we go along, we get another relative maximum and keep going along. And now we hear this other b value. Now, I didn't define these 2 points as c and b, but we'll notice that this b value, it creates a relative minimum. All right, so where do we look for absolute maximums? Well, on an open interval, remember the difference between an open interval and a closed interval is open means it continues on. Either it continues on or at a certain point it becomes undefined. Now, positive infinity and negative infinity, although we like to think they're real numbers, they're just abstract quantities. So we would consider a graph that goes with an arrow down and an arrow, that their absolute minimum, one might argue that it is at negative infinity, or some people might say that the absolute minimum does not exist. So I would argue that we might go to negative infinity as an absolute minimum. On the other side, we have an absolute maximum, right? An absolute maximum, and that the function continues to go to positive infinity, so or an absolute maximum there at positive infinity. Now, what would happen if we decided to narrow down or put in a closed interval? So what we have here is a closed interval from -1 to 4. And essentially what I would end up doing is at -1 here, I'm just going to draw a straight line, because now I'm going to close this interval. I'm going to close this interval now from -1 to 4. So now we're looking at a very tight-knit situation. Everything basically from the left of -1, we're not too concerned with anymore. Well, look what happened. We lost a relative max, but we still have one here. So now this would be the c value that we would talk about. As we find a c and we find that critical value, then we will know that it produces a relative maximum. We still have relative minimums here and here within 4. But now we start to discuss absolute minimums or absolute maximums. We might say, well, look, for the minimum case, for our minimums, well, which is lower, this value or this value? Well, this one is the lower of the two minimums, so we would argue that that is a relative, but it's also, for this closed interval from -1 to 4, because we've closed it now, is also our absolute minimum. Just for the 1 to 4, -1 to 4 interval, okay? Now we might also take a look at our, well, this is our relative max, but what happened to our absolute maximum? Well, as you can see, this point is still higher than any of the other x values, except when we get up here to 4, now suddenly at this point of the function we have a dot, and so we would then call that our absolute max on the interval from -1 to 4. Okay? So again, critical points. What are they? What do they do? Critical points are, we set the first derivative equal to 0. We solve for x. Then these x values will be substituted back into f of x, or the original function, the position function, and that will give us our critical points, okay? Which are the maximum and minimum points on the graph. All right, well, let's see it as a live example of what we do with this. So here's example number 1, and it says, move this up a little bit, and it says we want to find the maximum and minimum on the interval from -1 to 5. All right, and so what we have here is our function is f of x equals x cubed minus 3x squared. And what we want to do is find our critical points. So we take the first derivative, f prime of x is equal to 3x squared minus 6x. We can factor out of 3x. We get 3x and x minus 2. Set those equal to 0. Then set each piece equal to 0, so 3x equals 0 and x minus 2 equals 0. And we get x and 2 as our critical points. Now, then what we do is we want to set up a table. Now, sometimes we'll choose to do a line graph or a table. Either one is acceptable. But what we do is we basically put our furthermost left x value in and our furthermost right x value. And then we put in our critical x values that we found here. Okay, these are our critical x values. And what we want to do is then input some test values to see, well, what is happening on this curve for us. And we choose a number between -1 and 0. We just chose -1/2. And now what I want to do is plug that in here. And if I plug a -1/2 into this equation, then I will get, and really what I'm looking for is the sign. What is it? Is it a positive or a negative? And that will indicate the slope. I'm not looking necessarily for a value of the slope as much as a sign. Is it positive or is it negative? So if I put in -1/2, that's a negative number. This will also be a negative once I multiply there or add that in, and I get a positive number. So I put in 0. 0 would just be 0, so we already know that that's a horizontal line. 1, that's a positive number. This would be a negative number, so we get a negative slope. This is a 0 slope again. And then if I plug in 3, substitute 3 in, this is going to be a positive number. 3 minus 2 is a positive. So a positive times a positive is a positive, and we get a slope. Now, we might have some recognition of what a cubic looks like, and if you follow the same instructions, you would see that it goes positive, horizontal, negative, horizontal, and then positive. And that's basically the behavior of a cubic function. And so what we've done, and then what we'd want to do is plug in maybe some y values, or the zeros, where the derivative is 0, 0 and 2, into the function. And if we do that, if we plug 0 in, we get 0. So I've got a maximum at 0 0. So we would say then we have a maximum at 0, 0, or a relative maximum. And then I have a relative minimum, min, at 2, negative 4. So relative max at 0, 0, and a relative min at 2, negative 4. Absolute min, we could figure out what that x value is, and an absolute max at 5, and an absolute min at negative 1. Anyway, hope that's helped. Anyway, enjoy. Have a great night. We'll talk to you soon. Have fun with some calculus. Bye.